Hey, welcome back. This brings us on to a really cool topic. So, if you've got a molecule like HCN, it turns out there's actually two possible Lewis structures you could have drawn. There's one that looks something like that, and there's one that looks something like that. And you might say, well, which one is the best one? So we know we put the more electronegative atom on the outside and the less electronegative on the inside. So we might probably guess this one is correct, and actually is the correct one. But let's say we weren't sure. Let's say we had a more complicated one and we couldn't use that simple rule. What we could do is we could find the best structure by calculating the formal charges, and whichever one has the lowest set of formal charges is actually the winner. Now, how do we do that? So we take each one of these structures and we say originally it's just the group number, and now we just assign half of the bonds and 100% of the lone pairs. So it's 1, 4, and 5. And so the formal charges for these are 0, 0, and 0. And if we look at the structure down below and we look at original, and now informal, it is 1, 4, and 5. I'm sorry, 1, 5, and 4, right? Because we got to go off the groups, and I just renumbered that one, didn't I? That was silly. And now what do we have? We have 1, and let's have a look at the center one. So you've got half that bond and half of that triple bond. So that's 1, 2, 3, 4, right? So each bond is 2 electrons, but half of it is just 1. And the outer carbon on the end, right, it's got both that lone pair, right? It gets to keep 100% of that lone pair, so 1, 2, and it's got half of each one of those bonds there, so 3, 4, 5. And we can see at this point here, formally, hydrogen has no charge. Nitrogen has lost an electron, so it's got a 1 positive charge. And the carbon at the end has gained an electron, right? So it started with 4, and now it has 5, so it has a 1 minus charge. And if we look at that, right, we can say, well, that's not the lowest set, so this is the lowest set. So we can say this one is the preferred one, and this one is the yucky one. So what do I mean by the lowest set of formal charges? So what it really means is you are taking the sum of the formal charges, right, and you're taking the absolute value of them. So for instance, in this bottom one over here, right, when I'm adding those up, of course they add up to the overall charge of 0, but I'm taking 0 and I'm adding it to the absolute value of positive 1 and adding it to the absolute value of minus 1. And of course, the first two numbers aren't changed. So that's 0, that's 1, but that's also 1. So that adds up to a total of 2, whereas we can see 0 plus 0 plus 0 adds up to a total of 0. So that's the lowest one. That's not the lowest one. So this is actually the proper, or best, I suppose, skeleton structure. So let's look at an interesting case, and that is of N2O. N2O is laughing gas, and it turns out experimentally the nitrogen is in the center of this molecule. So if you do some X-ray diffraction, you can tell the oxygen atom is actually on the outside and the nitrogen's in the center. And you might say, well, okay, that's fine. Well, maybe I'll write a Lewis structure for it. And one Lewis structure looks something like that. And of course, the thing is, right, that it could be a triple bond on one side and a single bond on the other side. And so maybe it could look something like that. And maybe another possibility, right, is that it's a single bond on the left. And, oops, didn't mean to write that, did I? Single bond on the left and a triple bond on the right. So which one of these is the best? So formal charges to the rescue, right? So all we got to do is calculate formal charges. And we just need to take the original number. So nitrogens are in group 5. Oxygens are in group 6, so it is 556, 556, 556. That's a very boring number. And now, right, we count how many there are. So what do we get? We get all the lone pairs, that's 4, half of the bond, so that is a total of 6. And then we get, for the central nitrogen, we get half of each bond, so that's 4. And for the right-hand oxygen, we get to keep all the lone pairs, that's 4, half the ones in the bond, so that's a total of 6. And then we do the same thing across the way. So the nitrogen there is 5, and the nitrogen in the center gets half of all 4 of those bonds, so that's 4. And the oxygen on the right's got the 6 lone pairs plus half the bond, that is 7. And then the far right-hand resonance structure, we've got 6 from the lone pairs and half the bond, that's 7. We get 4 bonds, so half of each bond gives us 1, so that's 4 for 4 of them. 4 for 4. And the oxygen on the right, you get the lone pair and half of those triple bonds, so that is 1, 2, 3, 4, 5. Formally now, we just go ahead and say that this has gained an electron, this has lost an electron, this has no charge. In fact, we know that N2O is neutral, so we know that they all add up to 0. So here we go. So this is 0, it's lost an electron, so positive 1. it's gained an electron, -1. And on the far right-hand structure, we've gained 2 electrons, so that is, nope, that is -2, right? So electrons are negative. Okay, I always forget that. So -2. The nitrogen in the center has lost an electron, so it's +1. And the oxygen on the far right has lost an electron, so it's +1. And if we look at these sums of the absolute values of the formal charges, these sum up to 2. Essentially, you just take 1 plus 1 plus 0 and 2. And these sum up to 2 and 1 and 1, so that's a total of 4. So we can say that this is the worst structure. And the question is, which one of these is the best? And right now, right, we would say, well, they both add up to 2, so each one should be good. But the rule in case of a tie is that you can break the tie if you choose the structure with negative charges on the more electronegative atoms. So remember, electronegativity is how well the atom pulls electrons towards it. So presumably it'll be more stable if the negative charge is on the more electronegative atom. In fact, if we look over here, we can see the nitrogen, right, has got a negative charge. And if we look at the structure over here, we see that the negative charge is on the oxygen. So which atom's going to prefer to have a negative charge? And the answer is the more electronegative one, which is this one over here. So we're going to say that this is actually the preferred structure. So we're going to go ahead and say this one is probably the preferred one. The one on the left is pretty good. Okay, and the one on the right is actually pretty terrible. So if we were going to go ahead and we were going to take a blend of these, we might go ahead and say, well, 50% of the time it's the center one, and maybe 40% of the time it's the left-hand one, and maybe the one on the right is really terrible, so 10% of the time it might look something like that.